Okay, so we're dealing with this one, question 4 here, right? Which says Mukuka PLC's dividends per share expected to grow at 10% compounded rate for 5 years, and thereafter at a 6% at rate of 6%. If the current dividend DO is 2 kwacha per share and the required rate of return KE, which was cost of equity, is 14%, what is the value of the stock? So, colleagues, yes, this is how we value stocks or share. Yes, is that a question? Now, I've just started sharing it. I've just started sharing it now. Yes. So, we're trying to find the value of the stock using the dividend discount model. All right. Remember, there are always three scenarios in the dividend discount model. All right. No growth, constant growth. This is where you just have a growth rate for which stays at the same forever. Then the no growth means there's no growth rate. And then you've got the multi-stage growth. This is the multi-stage is where the dividends are growing at different rates. Okay. So here in this case, since the dividends are growing at 10%, then at 6%, you know you're dealing with multi-stage growth. Okay. And the dividend rate changes. So these are the steps that you need to remember when you're tabulating the value of a stock using dividend discount model for the multi-stage growth. Okay. Step one is calculate your expected dividends. Okay. Step one, calculate the expected dividends. Okay, colleagues. These expected dividends are the dividends we're expecting to receive in the upcoming years. Okay. Yes. And how we calculate the expected dividend, have you seen this formula here? D1 equals DO, open brackets 1 plus G. Yes. D1. Huh? Sure. Colleagues, can you see? How about the others? You can see the word document. Hmm. Yeah. Try to log in or log out. Yes. So I was saying, have you seen this formula here? D1 equals DO1 plus G. Yes, here we are calculating the expected dividends. Okay, since the dividends are growing at a 10% rate, so we want to know what are the dividends which will be paid out in the future. Okay, colleagues, we just want to find out what, how much are the dividends that we paid in the future. That's what the expected dividend is. Okay, so this is how you do it. Let me just put it make space here. So we're going to start with year one. Okay, which is the next year. Want to find out what will be the expected dividend for year one. Let me just put the formula here first so that as we are solving, we still remember the formula. Remember the growth rate is 10%. Okay, growth rate is 10%. Okay, so this growth factor 1 plus G be 1 plus 10% is 0.1 in decimal form. So the growth factor will be 1.1. Okay, colleagues, the growth factor is going to be 1.1. Okay, yes. So in year one, the expected dividend, all right, it's the current dividend DO, which is 2 kwacha, multiplied by our growth factor, which is 1.1. So 2 times 1.1, that is 2.2. So it means the dividend that will be paid in year one is 2 kwacha 20 ngwe. Any question? Yes, 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 yes. Here, madam. The current dividend is 2 kwacha per share. Okay, we move on to year two. Okay, year two, again, we're using this formula. So here it becomes D2. Because in the exam, I think you need to put things in order. So you put it like this first, so that you get the full marks. So the expected dividend for year two, we're going to use this formula here. We're going to say D2 equals D1. Okay, instead of D0 here, now we're using D1. The dividend for year one multiplied by the growth factor. Okay, so remember the dividend for year one was 2.2 kwacha. So this 2.2 kwacha multiplied by 1.1 equals 2.42. This is the dividend that is going to be paid in year two. Any questions before we get the dividend that will be paid in year three? Okay, dividend for year three, D3, is going to be the dividend for year two multiplied by the growth factor 1 plus G. Because this is how you have to show it in the exam so that you get all the marks. Okay. Yes. So the dividend for year two, 2.42 multiplied by the growth factor 1.1 is 2.66. So colleagues, all that is happening here is this. Each year the dividend is growing by 10%. Okay. That's what's happening here in simple words. Each year the dividend is growing by 10%. Okay. Yeah. So this dividend for year three is going to grow by 10%. That's the one that will be paid in year four. Okay. So in year four, the dividend for year three is growing by 10%. So you say D4 equals D3, the dividend for year three multiplied by the growth factor. Okay. So 2.6 multiplied by 1.10, that's 2 kwacha 93 ngwe. Okay. So this 2.66 grew by 10%. So in year five, this 2.93 is going to grow by 10%. Okay, so the dividend for year five is going to be D4 equals D. For D5 equals D4 multiplied by the growth factor. Okay, so the dividend for year four was 2.93. 2.93, if it grows by 10%, it becomes 3.22. Okay, yes. Any questions, colleagues, on step one? Okay, now remember, after 5 years, the growth rate is going to change. The growth rate is now going to be 6% until forever. Okay. The growth rate is going to be 6% until forever. All right. In perpetuity, it will just stay at 6%. It will never change. That is one of the limitations of this model, colleagues, this dividend discount model. These assumptions where they make that a growth rate can be forever. It's impossible. Okay. Yes. So in this case here, now we cannot do this process until we reach forever, right, colleagues? We can't start dividend for year six, year seven, year eight, year nine, year 10. We can't do that because we don't know when forever ends. Okay, we don't know when forever ends. So that's where you're going to hear about what is called the terminal value. Okay? What this terminal value is representing all the dividends that are going to be paid from year six until infinity. Okay. The terminal value, terminal value represents all the dividends that will be paid. Okay. All the dividends that will be paid, yeah, all the in perpetuity, basically. Okay. These dividends that will grow at 6% forever, all of them combined, that's what the terminal value is. All the dividends that will be paid when the growth rate stays the same forever. Okay, colleagues, that is what this terminal value is. Okay. So this is how we get to the terminal value. So I can put this also in step one so that we don't have many steps. So step one, calculate expected dividends and terminal value. Okay. So in this case, the terminal value equals the expected dividend for year six over the cost of equity minus the growth rate. Okay. Terminal value equals the expected dividend for year six. Okay, and that's why you have seen this D5, 1 plus G. We're saying that the dividend for year five, when it grows at 6%, what is it going to be? Then we divide that minus the cost of equity over the growth rate. Okay. So remember, the dividend for year five was 3.22. Okay. When the growth rate becomes 6%, so the growth factor 1 plus G equals 1 plus 0.06. That gives us 1.06. Okay, so this 1 plus G is 1.06, the growth factor. Okay, so we are saying this 3.22, if it grows by 6%, so we'll do 3.22 multiplied by 1.06. 3.412 3.4 3.413. Okay. This is the expected dividend for year six. Okay. Over the cost of equity in the question, cost of equity, they told us here KE is 14%. So that becomes 0.14. 0.14 minus the growth rate, which is 6%. So 0.14 minus 0.06, 0.08. Okay. So 3.413 divided by 0.08, you get 42.6625. So colleagues, this 42.66 is representing all the dividends from year six up to infinity. Okay. That's what this terminal value is representing. Okay. Any questions? Huh? Yes. Mm-mm. Yes, the total of the amount in perpetuity, madam. Those dividends from year six until infinity, you are combining all of them together. So it's the total of the perpetuity. Any other questions? Uh-huh. Uh-huh. You use it, madam, when the dividend rate changes. Okay, in the question, when the dividend rate changes, have you seen here at 10%, then it changes to 6%. So when you see that, yes, when you see that, oh, the rate of the dividends have changed, and one is going to be in perpetuity, then you apply the terminal value for the perpetual growth. But even for, is it, if they bring a question for the constant growth model, the constant growth model is the same like this one. If they tell you, okay, a company is, they expect the dividend rate to be 6% into the foreseeable future, calculate the value of the dividend. When you just see one dividend rate, constant growth rate, you also use this formula. So two scenarios, okay, madam? When there's only one growth rate, here it will just be the, this formula will be used to just get the value of the shares. That's all. You just have to do this formula and you get value of value. Yes. Then if it's Okay, step two, all of these future dividends, you get the present values, okay? Get the present values for all expected dividends, including also this one for the terminal value, okay? So remember, present value formula, it comes in two forms. You can say present value equals future value 1 plus r to the power negative t, or you can say future value over 1 plus r to the power t, whichever formula you're okay with. They're supposed to yield, if you know the exact answer, but the answers will be very close to each other. Okay. So these dividends here, this 2.2, this 2.42, this 2.66, this 2.93, this 3.2, we have to get their present values. Even this terminal value, which represents the total value of the perpetual dividends, the dividends in perpetuity, we have to get its present value. So this is the assumption, colleagues. This dividend will be paid at the end of year one. This one will be paid at the end of year two. This one will be paid at the end of year three. This one will be paid at the end of year four. Then in year five, you're going to be paid this dividend at the end plus this terminal value. Okay, in year five, you're being paid the perpetual dividends and also the expected dividend for year five. So do not make a mistake when getting the present values. Like in this case, you say for this perpetual dividends, you said you discount it to the year six. No. Okay. This will be paid at the end of year five with expected dividend for year five. Okay. So for me, I use this formula here. Present value equals future value over 1 plus r to the power t. Our discount rate, always remember, KE is the discount rate. So do not discount this. Like here, this dividend, you discount it at 10%, this one at 10%. No. You're discounting all the dividends with the cost of equity. So our discount rate, KE cost of equity, is 14%. Okay, that's why you can see a 1.14 in the denominators here. Okay, this 1 plus r, remember, 1 plus 0.14 equals 1.14. Okay, our discount factor. So have you seen the dividend for year one, 2.2 over 1.14 raised to the power 1. The dividend for year two, 2.42 over 1.14 raised to the power 2. The dividend for year three, 2.66 over 1.14 raised to the power 3. The dividend for year 4, 2.93 over 1.14 raised to the power 4. Then for year 5, the dividend for year 5 plus the perpetual dividends over 1.14 raised to the power 5. So when you do our tabulations, you get 1.93 plus 1.86 plus 1.8 plus 1.14 plus 23.8. That gives us 31 kwacha 13 ngwe. That is the value of the shares for this company. Okay. This is how much this company should sell its shares for, 31 kwacha. I forgot to mention in the beginning of this question that the concept we're using to value the shares here is this. The value of the share is the present value of all the payments that are going to be made from that share. Okay. So here, remember all these dividends that we calculated, all these payments, we converted them into the present value so that we can get the value of the share. Okay. It's similar to saying you build a house and then you say, okay, the value of my house is going to be the present value of all the rent that I'll receive in the future. So the rent you receive in year 1, year 2, year 3, year 4, year 5, year 6, maybe say up to 10 years, up to year 10, all that rent that you receive, you convert it into today's value, and that's how much you value your house for. Any questions, colleagues?